Welcome back, and we're looking at end behavior of polynomial functions. Let's go back for a few minutes to something we know about and think about the end behavior of those. Our parent graph y equals x squared that we played around with earlier, if you'll remember, makes a U-shaped graph up. And you remember if we put a minus sign, it's reflected in the x-axis, so it turns down. All right, we looked at the parent graph for y equals x cubed. And if you didn't kind of learn the shape then, you can learn it now. It has that little wiggle. Well, if we reflect it, then it looks more like this. Notice something. We have an even degree here. So we're dealing with an even degree. Let's don't put it up that high. Let's move it here. For both of these, we have an even degree, and both ends do the same thing with a positive lead coefficient. This understood 1 right here. Both ends go up with a negative lead coefficient. Both ends turn down. Now notice right here that we are dealing with odd degree, y to the third. And again, things change depending on whether the lead coefficient is positive or negative. Right here, we have a positive lead coefficient. And here, we have a negative lead coefficient. So when it's of odd degree, the ends do different things. When the lead coefficient is positive, it rises to the right, falls to the left. When the lead coefficient is negative, it rises to the left and falls to the right. So the first thing we're going to do in looking at degrees and end behavior is to notice whether the degree is even or odd. Then we'll choose either y equals x squared, y equals negative x squared, y equals x cubed, or y equals negative x cubed by both whether it's an even or odd degree and whether or not the lead coefficient is positive or negative. So while it may do something different in the middle, it's going to do the same thing at the end that one of these graphs does. So let's make up one here while we still have our directions here to follow. Let's say that we're going to draw a polynomial that looks like this. Can we decide whether it's of even or odd degree? Sure, both ends do the same thing, so we know the degree is even. Since both ends turn down, it follows the pattern of minus x squared, so the lead coefficient is negative. Okay? Even degree because both ends do the same thing. They both turn down, therefore the lead coefficient is negative. That wasn't hard, was it? Well, let's come up with another one and see if we can tell something about the end behavior of it. So let's erase what we have for our sample and do another one. Let's do one that looks like this. It just jumps around all kinds of ways, but finally goes up at one side, down at the other. Since the ends are doing opposite things, we know we have odd degree. Now, since it's rising to the right and falling to the left, I come over here and I look. This one right here is rising to the right, falling to the left. So that means it has a positive lead coefficient. Now, can we go the other direction? Let's see if we can. We have a function given to us, and we're going to use the leading coefficient test to determine the end behavior for this. First of all, I notice that the degree is even. So that means it follows either y equals x squared that turns up on both ends, or y equals opposite of x squared, which turns down on both ends, because it's of even degree. Now I look and see that the coefficient is positive. This is my positive coefficient for my samples. Since y equals x squared with the positive coefficient here turns up, we're going to say that it rises to the right and falls to the left. Okay, not hard, is it? So we see that using the lead coefficient test to test for end behavior is relatively easy. Next, we're going to look at zeros of polynomial functions.